Okay, objective 7, which people listed as one they wanted to see a little more about. You have an equation, and if it's linear or quadratic, you want to put it into the linear or quadratic form. Now, you don't always know in advance whether it's going to end up in the linear or quadratic form, but if you just follow certain procedures, certain things like what we're going to call, I want to use the word heuristics, but nobody knows what that means. So, okay, maybe I don't. Anyhow, we got linear and quadratic equations. What we do to solve any equation is we try to put it into this form, ax plus b equals cx plus d, or this form, ax squared plus bx plus c equals 0. Once we get it into this form, everybody knows what to do. Everybody seems to be doing it right. If we get it into this form, well, we solve either by factoring, completing the square, or using the quadratic formula. Okay, so we're just going to talk about how to put it into this form or this form, because everybody knows how to use a quadratic formula, and I think everybody's pretty good with factoring. Not sure anybody knows about completing the square, but we'll be covering that later. Okay, and everybody's supposed to know completing the square. I don't know if anybody remembers it. So, one basic principle. If there are denominators, you multiply each term by a common denominator, preferably by the least common denominator. Something we've been talking about for a while, and people are getting pretty good about it, but people still want to make it harder on themselves by not doing that. Okay, they don't really want to make it harder on themselves, but they don't think to do that. A lot of people do not think to do this. So we want to be sure that we do this. Okay, so here's an equation. Now it's very simple. Your common denominator just plain old 5 times 7, which is 35. Okay, so we'll multiply x over 7 by 35. And this is another term. Terms are what you separate with pluses and minuses and equal signs. Okay, so we multiply 35 by 3. And we get this. And then these can be rearranged. Okay, we have, we can write this as 35 over 7 times x over 1. 35 times 3 is 105. And we could write this as 35 over 5 times 4x over 1. And then 35 divided by 7 is 5. X over 1 is just x. So we have 5x. And we have 105. And then we have 7 times 4x. And at this point, I assume everybody knows what to do. I'm not going to take time to do this. You're going to multiply the 7 by 4x. You're going to get 28x. Then you divide or subtract 28x from both sides, subtract 105 from both sides, and you end up with negative 23x equals 105. X is 105 over 23. You want to do that carefully, but that's it. So we've reduced this to this form. Okay? Now, not quite to this form, because you're going to multiply 7 by 4 to get your cx. Your d would be 0. Ax plus b is here. Okay, so you got it. Okay, so let's see what happens with this one. Okay, we've got a common denominator is now 5 times x. So common denominator 5x for this equation. So we're going to multiply 5x times 7 over x plus 5x, and we'll write it as 5x over 1 times 7 over x, and then 5x times 3, and then 5x over 1 times 4x over 5. Well, using what we know about fractions, we know this is going to be 35x over x. And this is 15, that's not equal, it's plus 15x. And that's going to be what? 20x squared over 5. And I didn't really leave myself a lot of room here, so I'm going to rewrite this real quickly. And I'll get rid of this. Okay. Now, I can write this as 35 over 1 times x over x, and this is just 15x, and this is going to be 20 over 5 times x squared over 1. Well, 35 over 1 is just 35. X over x is just 1. 35 times 1 is 35. We still have our 15x. This is going to be 4 times x squared over 1, which is 4x squared. Okay? Now at this stage, people often try to rearrange it like they would a linear equation, and you never get it to work. Or you might fool yourself into thinking you get it to work, but you can't do it. So you have to recognize at this point, here's an x squared, here's an x, and here's a constant term. This is an equation that has an x squared, an x, and a constant term, so that if we just rearrange it, we can put it into this form, and that's easy enough to do. We subtract 4x squared from both sides, so we get, and you really do want to show all the steps as we've done in class. So I'll put some dots in here to indicate there are some steps you should include. You know, this minus the 4x squared equals this minus the 4x squared. And then you do some rearrangement. But there we have it. And this is now a quadratic equation. And we solve using the quadratic formula. So I'm not going to complete that solution. Plug into the quadratic formula and do the numbers. You could try to factor it. I think you'd be out of luck, but I haven't tried, so. And I could actually check the discriminant. It's going to be 225 plus 140, which is 365. Not a perfect square, it's not going to factor. And hopefully you know what I just said, but if you don't, it's okay for now. But that's something you should know. Know what I just said from prerequisite courses. Okay. Okay, well, let's look at this one now. Okay. Our common denominator is 5 times the quantity x minus 2. I could multiply that out to 5x minus 10, but it's a lot easier if I just leave it factored. And these would have actually maybe been a little easier if we'd have left it factored, but here we really want to do that. Okay, so we multiply. Do this. Okay. And I'm putting the 1 in the denominator because people are still showing some confusion with fractions. Okay, so then we're going to have 5 times x minus 2 times 3 times x plus 1. And then it's going to be 5 times x minus 2 times 4x over 5. So we've got to put that over 1 since we've got a fraction. Now it looks like an exponent, but the multiplication tells us that it isn't. Okay. So what do we do here? Well, look, this is the same as x minus 2 over x minus 2. I'm getting ahead of myself there. Times I'll write the 5 times 7 over 1. Debating about whether to multiply that out now, but I'll do it in the next step. Then 5 times x minus 2 times 3 times x plus 1. Well, I can simplify that in one step. 3 times 5 is 15. And then if I multiply x minus 2 times x plus 1 using the distributive law, and I don't want to go through all the details of the distributive law here, but we're going to get x squared minus x minus 2. I multiply the x minus 2 times the x plus 1. It's x times the x plus 1, which gives an x squared plus x, then minus 2 times x plus 1, which gives us minus 2x minus 2. So we have a 1x and a minus 2 and an x squared. And you have to write that out. You won't necessarily understand it from my saying it, but you should get the idea. And we do want to multiply this using the distributive law, but right now I'll accept whatever method you use. And people seem to be doing multiplying binomials pretty much correctly, so I'm not going to address that right now. Okay, over here, well, we got a 5 over 5 by rearranging. Then we got x minus 2 times 4x over 1. And we can see that if we multiply this out, we get the same as if we multiply this out, so it's equivalent. X minus 2 over x minus 2 is 1. Multiply that by 35 over 1, and we get 35. Again, there are some dots here. There are things you want to show. And then we get 15x squared minus 15x minus 30. And then this equals, well, x minus 2 times 4x. 5 over 5 is 1. And this over 1 is just what it is. And that's going to give us, by the distributive law, x times 4x is 4x squared. Negative 2 times 4x is minus 8x. And now we just subtract this expression from both sides. I'll write it out. We get 35 plus 15x squared minus 15x minus 30 minus 4x squared plus 8x equals 0. You got to be careful. You really want to write out the intermediate step. Minus the quantity 4x squared minus 8x, and then you distribute the negative sign through. So you got to do that step correctly. But what we're after right now, and what we want to illustrate is we want to move toward the quadratic, the general quadratic form of an equation. So we got 15x squared minus 4x squared is 11x squared. And we've got negative 15x plus 8x, which is going to give us negative 7x. And then we've got 35, and we've got negative 30, so that's minus 5 equals 0. So this is a little more complicated, a little more involved, but just using standard algebra, it's pretty easy to do this if you know to multiply by the common denominator and if you understand how to multiply fractions. So there we have it. And then use a quadratic formula. Okay, one more equation. Here our common denominator is 5x times x minus 2. So we have It's a bad looking 3, but we're going to take it anyway. Okay. And I didn't leave myself room to write out the entire expression, so I'm going to do 5x times x minus 2 times 4 over 5 times x minus 2. And I've been writing the over 1 here, so it's a little lopsided, but there it is. Okay. Well, 5x times x minus 2 is 5x squared minus 10x times 7, and 5x times x up get a little sloppy. I didn't put my x in here, so there we have it. And then we have this, and that's going to equal I don't like what I did here. When I multiplied the 5x times x minus 2 times 7, I didn't have an x in the denominator. Okay? And now that I have an x in the denominator, I really don't want to multiply this out. So I didn't read carefully enough. A little error there. Not that what I wrote isn't equivalent to what I have, but it's not really going to get me where I want to go as quickly as it should. Okay, so this 5x times x minus 2 times 7 over x. Got an x here and an x here. Now, reflex would be cross those out, use the cancellation. We don't do cancellation. We rearrange. So we're going to write this as x over x times 5 times x minus 2 times 7 over 1. Okay? So then the x's will divide out. This term is fine the way it is, but this last term, we're going to have, we have an x minus 2 here and an x minus 2 here. So we're going to write it like this. And then it's, we've got a 5 here and a 5 here. So we'll match those up. And then we just have 4 over 1. So here we have the entire numerator, except the x, which I need over here. Okay, we got the 5 there. We've got the x now here. We've got the x minus 2 here, and we've got the 4 here. In the denominator, we have our 5 here and our x minus 2 here, and multiplying by 1 doesn't change that. Okay, so now what do we have? X over x is just 1, and that's times 5 times x minus 2 times 7. So this is 1 times 35 times x minus 2. And now multiplying through by the 3, we have 15x squared minus 30x. And that's equal to 4x. Getting a little shorter, which is good because we get a little less room here. Okay, well, 1 is multiplied by all the rest of this. We can ignore it. We have 35x minus 70 if we multiply this one out. And then we have plus 15x squared minus 30x equals 4x. And I've got another error here because this is a linear equation. I'm going to have to leave this in. I take it back. Turns out it isn't linear, is it? Okay. Yeah, okay, never mind. Okay. So here we have it. And now we do the rearrangement. We're going to have, I'm going to put dots here, but there we have it. Subtracting the 4x from both sides. The dots mean you need to show that step. And then we have what? 35x and minus 30x and minus 4x. That just gives us x. And we got 15x squared. And then we have minus 70 equals 0. Okay? Now again, I don't think you're likely to get this to factor. 15 times 7 is 1,050. 4 times that, 4,000, 4,200. And then we have 1. It's going to give us 4,201, which is not a perfect square. So this doesn't factor, so we use the quadratic formula. Okay, well that illustrates a lot of the things that can happen if you have denominators in a linear or quadratic equation. Doesn't look necessarily like a linear equation. On this one, I intended it to be linear, then I did something and forgot that I'd done it and that it didn't make it linear. So it looked linear to me for a minute until I thought about it, until I got down here and found out that it wasn't. So naturally I pretended to think it was linear and then saw what happens when I prove myself wrong. Well, I wasn't pretending. Okay, so there we have it. Here's one that does end up linear. These others end up quadratic. You want to be alert to whether an equation ends up linear or quadratic. Of course, there are equations that end up neither linear nor quadratic, but right now, that's what you're going to see.